This is the 8th experiment of digital design. Here we'll be discussing about what are comparators. Comparators in general, what do I want to do? I want to compare either two bits or two numbers. First of all, starting with two bits. If I want to compare two bits, that means what are the possibilities? Either one can be greater than the other one, or equal to, or less than. That's how it is compared, right? So how do I say that anyone is greater? In terms of binary, there are only two possibilities. Either anything can be 1 or 0. So if I say that I want to compare A and B, then that means A has to be 1, B has to be 0. Then I can say that A is greater than B. Then similarly, if I say that A has to be less than B, then A has to be 0, B has to be 1. Now, obviously, for equal to, you have two possibilities. Either both are 0 or both are 1. So, here I have, if A is greater than B, then A is 1, B is 0. That means, in main terms, we read that if anything is 1, then kept as it is, 0, that means bar. So, the function is A, B bar. Similarly, if A is less than B, A is 0, B is 1, so function is A bar B. And if A is equal to B, then either A is equal to 0, B is equal to 0, or both are 1. So that means that the function is A bar B bar for A is equal to 0, B is equal to 0, or AB. Or means plus, sorry, plus not XOR. Fine. So the function is A bar B, AB bar, and A bar AB plus A bar B bar. Important part to note about this is that this is an XOR function. So XOR function will be an invert of XOR function, which is AB bar plus A bar B of XOR. So I mean invert. So this gives me A XOR B bar. Now to implement this is straightforward. You have A bar B added together to get A bar B, or this is AB bar, and this is A bar B, and that all not to, I mean this is a NOR gate to give you A bar B plus AB bar complement. So this is A equal to B, this is A greater than B, this is A less than B. This is a general comparator using or comparing just one bit. But in general, we'll be doing, at least for lab, we did for 5 bits. So let's see how comparison for more than 1 bit works. Just for suppose you have to compare two bits 4, 3, 2, 1, 5, 6, 7, 8, okay, or 4 bits. These are two 4-bit numbers. What do I do? First of all, to compare them, which one is greater? I see the MSB or the maximum number. I see that 4 is less than 5, so obviously this number in total is smaller than the lower number, right? So this is the first bit comparison. Just suppose that this is also 5. If this is 5, what do I do? Okay, first bit is same. If both the first bits of both the numbers are same, then go to the second bit. Now 3 is less than 6, so this number is smaller than the other number. If these are also the same, then what do I do? This is also the same, this is also the same, so go to the third number and compare the bits. Now 2 is less than 7, so first number is less than the smaller number. If suppose this is also same, then what do? I compare that first was same, second was also same, third was also same. So now compare these two, because 1 is less than 8, so the first number is smaller than the second number. This is a general idea of comparison. Similarly, you have 4 bits to compare. A3, A2, A1, A0, B3, B2, B1, B0, MSB, LSB. Now how do I compare? First of all, for A greater than B, let's see the logic. For this to be greater than this, first of all, bit by bit comparison. So A3 should be greater than B3. If A3 is greater than B3, that means this is 1, this is 0. So A3 B3 bar means that this number is greater than this number, A3 B3 bar. If this does not happen, that means they are equal and these have to be compared. So let X I denote that AI is greater than AI is equal to BI. That means if I say X2, that means A2 is equal to B2. So here X3, that means either the first bit has to be same, or sorry, A3 has to be greater than B3, or A3 is equal to B3 and A2 is greater than B2. Similar. So what I say is X3, or I can say, see, initially I said A3 is greater than B3, either this can happen, or it is, or A3 is equal to B3 and A2 is greater than B3. This is second option, right? Third option is, or A3 is equal to B3 and A2 is equal to B2 and A1 is greater than B1. This is the third option. So similar is A3 B3 bar for this, X3 for this, A2 B2 bar for this, or A3 is equal to B3 for this, A2 is equal to B2 for X2, A1 is greater than B1 for A1 B1 bar, and similarly for the third logic that A0 should be greater than B0, you have X3, X2, X1 and A0 B1 bar. So this is how general logic for A greater than B will work. Similar thing, if A3 bar B3 is done, then you will have for A less than B, and for A equal to B, you will have either this is equal, or this has to be equal, and this has to be equal, and this has to be equal, and this has to be equal. So in general, for A equal to B, if I am comparing 4 bits, then each and every bit has to be the same. So for that, I can directly say X3, that is A3 is equal to B3, and A2 is equal to B2, and A1 is equal to B1, and A0 is equal to B1. This is A equal to B. So this is general comparison. Now, how does it implement in a normal circuit? I have this. So comparison is being done at 5 bits. In general, IC7485 is used to compare just 4 bits. So I am giving A3, A2, A1, A0, A3, A2, B3, B2, B1, B0 as the inputs. 4 bits are being compared, and the fifth bit is being added separately using this. The output is being fed in over here in this. When this output is fed, this is compared and the final result is calculated. The whole result is can be seen in terms of the CRO or through LEDs or anything that is required or asked in lab. So this is how experiment 8 general comparator works.